Operations we can do on vectors, linear combinations, the span of a set of vectors, and the standard basis vectors. The operations we can do on vectors is to add one vector to another. This is the most basic operations. There are more, but the most basic is you take one vector, take another one, and you add them one to another. Another even more basic operation we can do on vectors is scalar multiplication. So if we have the vector from the 2 dimensions to 1, and we scalar multiply it, by scalar we mean a single number, by 2, then we have 2 times 2, 1, so we have 4, 2. This is the output vector. So we have seen that we can have two very basic operations on vectors. We have more, but these are the most basic, the vector addition and the scalar multiplication. The linear combination of a set of vectors is, let's say that we have 4 vectors, be whatever they are, and in whatever dimension. By dimension, we mean the number of items that we have on the vector. So if we have 2 items on the vectors, let's take the vector 2, 1 again, then this is 2-dimensional vectors from the 2-dimensional space. So by linear combination, we take we look at a set of vectors that we have. Let's say that we have 3 vectors from 2 dimensions, 2, 1, 3, 1, and 4, 1. These are 2 vectors from the 2 dimensions. By the linear combination of them, we mean that we multiply each of the vector by a scalar, and thus and we add them. Okay, so we use the 2 basic operations that we've specified. What were the 2 basic operations that we have specified on vectors? We have specified vector addition and scalar multiplication. So if we take scalar multiplication and we multiply each of a vector that we have on a set, and then add the result of the scalar multiplications, then we get the linear combinations of these vectors. Okay, and the next step is to take the set of all linear combinations on these vectors. So if we have, let's call the vectors a1 to an. So let's say that we have such n vectors, and we take all the possible linear combinations of this vector. This would basically cover up all the space that we have. So if we have 2, 1 and 3, 1, those would be 2 vectors. And then we start multiplying them by 2, 1, we multiply by x1, which is a scalar, and 3, 1, we multiply by another scalar. Then we take another one and multiply and add, multiply and add, multiply and add. Each time we get a resulting result vector. So basically we are taking all the input vectors that we have and we are getting a single vector. But then we do it again with different multiplications and additions, and we get another vector. And we do it infinite number of times. We take all the possible combinations, and we can have a couple of results from this. We can either cover up all the space, or we can get only a line, depending on the vectors that we have as the input. Or we can get a single dot. If we have as an input, let's say the vector only 0, 0, 0 into the 2-dimensional space, then it doesn't matter. And this is the only vector that we have. Then it doesn't matter on which scalar we multiply it and how many times we add it to itself. We'll always end up on the 0, 0 position. To the last item, the standard basis vector is when we have, let's say, R2, which means the space of 2 dimensions. Then the standard vector would be 0, 1 and 1, 0. 2 vectors, 0, 1 and 1, 0. And if we were in the 3-dimensional space, then we would have 1, 0, 0, 0, 1, 0, and 0, 0, 1. And it's very a nice vector, the standard basis vector, because with these standard basics vectors, we can represent the whole space, because we can take on the span and the linear combinations of them and cover up the whole space. So that was it for the basic operations on vectors, vector addition, scalar multiplication, linear combination, the span of vectors, and the standard basis vectors.